Yeah, no code. All right. So these are the three things that we're going to look at as applications of integration, right? Finding the area under the graph, which you know already, volume of revolution, all these you know from CSEC. But we just go and add, right? We just go and add a slight twist to them, right? So the first one, which is area under the graph, if I give you a function like this, between A and B, and I ask you to find the area there, right? This area here is equal to the integral between B and A of whatever the function is, right? All these things we know already. Yeah, but let's figure it out. Think we know, okay, right? But what will happen? What will happen if you have something like this? Between A and B. No, it's not identical. It's not identical. Right?
And I'll try where to intersect the y-axis.
Very good.
The x-axis, sorry.
Right.
And then that would be 1 point, keep it as C.
Right.
Right. And then you find between A and C, and then B and C. And if you want total area, you add them. If you want.
Forget something. The area here will always give you a positive answer. The area here is negative. So to get the total area here, we integrate between C and A, right? We integrate f of x between C and A, and then we not add it, we minus it. Or you could do that here. You could flip it around, right? But then we integrate in between between B and C f of x. Right? You put in negative sign in front of the part below the axis. That's okay? Right? Also, suppose on the other hand, I ask you to do it like this. I ask you to integrate now. I ask you to integrate now between the y-axis. Right? How will the formula change now?
So it's x
right. So what you're going to do now is integrate between C and D. Instead of f of x, turn it to
y.
F of y and respect to y. Okay? But suppose now the function is below the x-axis. Sorry, it's on the next side here. Suppose it looks like this. Suppose the function looks like that. That's not, but that's smooth it up a little. Suppose across the y-axis, suppose it looks like this. And you want to get the total area between point C and point D. Same principle.
Same principle.
Right? Same principle. Here's positive, here's negative. So you need to get C. That's okay?
Yeah.
And last one, 1, 2, 3. Last one. Suppose you had a function looking like this. Suppose you had a function looking like this. That's f of x, and this is g of x. How do you get the area in between now?
So let it find the no, go ahead.
Right, so simultaneously, let's say it's A and B, and then what?
And then find the area,
Now, easier than that. Right, instead, Victoria, of doing it individually, right? What you can do is, which one will produce a larger area? F of x or g of x? F of x, right? This will produce a larger area. You're seeing that? So suppose I found the area of f of x and the area of g of x and minus them. And that will get here?
Yeah.
Right? So instead of doing what Darian said, right? Instead of doing what Darian said, I'm taking 2 hours to do that. See what you can do? Yeah, what you can do, right? You can minus f of x and g of x. Don't integrate them separately. Do them as one. And then and then the ends. That's okay? So you can just minus the one on top. You have to always figure out Jaden who on top. And then minus 3 of x. You have to laugh one time. You have to laugh one time. Alright, so those are the things that we need to remember for area. Area is more popular than volume, but alright, online. Right? This one is very important because, right, in the past 3-4 years, this came, right? And you had to figure out the equation on top and then work it out. Yeah, guaranteed. Guaranteed.
So it's a dollar value.
Darian, watch boy. Oh yeah. Copy that down. Let's take a look at number. Any questions online? All right, so watch this one here. Whenever your function go below the x-axis, that area will be negative. So if you integrate between b and c, that'll be a negative area. So if you add a negative area to a positive, you make the actual area smaller. So once you identify it below the x-axis, you place a negative sign in front of that integral. So that negative and negative will cancel and you'll get the full area. Here, if instead of asking you across the x-axis, between the x, they ask between the y. Stays the same, but you need the limits across the y and the function in terms of y. Okay, here is just like that. If it goes across the x-axis, across the y-axis, here negative, here positive. This one is the very important one. You listen to this one. I wasn't listening as well. No, fine. We're very bad, fine. So you want to get the area in the middle here, right? To get it, did I record this stuff? Right? To get the area in the middle here, there are 2 ways you can do it. You solve these 2 simultaneously, you find where they intersect. That'll be your limits, right? And then you can find the area under the bigger one, which is that. Find the area underneath here. And then find the area underneath G and minus it. Or since instead of doing them separately, you can do it together one time. Just minus the one on top from the one underneath, and then it. So instead of doing what Darian said to integrate this and then minus. Right? Don't do that, right? That will take real long. Right, so there's some rules for you to remember, right? Especially the last one, because that's the one I might see in exam, right? Huh? Not for you, but for you. Not for you, but.
Just see.
Shut up on my thing now, boy.
Right. Rules for volume online of the day. Oh, I'm pretty thing in the belt.
Okay.
Right, so what you see? All right, and so
Yes.
yeah. Go to what? This one's a volume in application or integration. So after you write that, there's have two things that you need to remember is that if you want to find the volume when you rotate a function 360 degrees, right? There's the formula you're using. What you have to remember is that when it's across the x-axis, you have to square the f of x function. If it's across the y-axis, like this, you have to square the function in terms of y. Okay? Here's in terms of x, here's in terms of y. Right, now let's make a note in case. Oh yeah. Hurry. Right, sit down quick. Oh yeah, copy on the next slide and then let's move to the question. Yeah. Alright, let's go. Next one. Right, so do the integration of next. Equal to that. All right, ready?
Yes.
All right, so there's a question on 20. Yeah, the same concept, whenever it goes across the y-axis. It's, across the y-axis, it will take some time with you. This one. All right, ready? Let's try this one here. This is 2017. I think we did not tell 2017 or something. You point at the other, yeah, watch the video, right? Huh? Which one is that? No, I was just playing and I'm a full time and I was excited. I just realized you see me in that video.
Sinabi niyo, rather Rocky by t-shirt.
Huh?
You look like you when you're on the shoot and our videos.
Well, I don't say that earlier.
You look like it need to be
That was the point, boy. Alright, so let's take a look at this. Oh, hold on. Alright, what's this one here? So they want us to find area. Right, what's this here? They want us now to find the equation and then find the area. In fact, I should give it this one. 2017. I'm gonna give you the one with the diagram too, right? Right, the year before they asked the same thing, but they gave you a diagram. Hold on there. Do this one again. Yeah, but we didn't do the first part. Well, the problem here, again, on the. Let me start my one. Just now, let's again, no problem, my, but 2015, you have it? Yeah, what, just take a picture and send a group from it, 2015, number 16. Take a picture, man. Take a picture and no, 60. Next time. There you go, now you know. Yeah. Nice. Okay. Right, so what is here? It'll also be on the group, right? Look at this here. You want us to get the area of that shaded region. Right, Victoria? They want us to get the area of that shaded region, right? That shaded area is technically a triangle. But they want us to use that integration method to find the area. Okay? So you're going to have to use the rule I showed you here. Right? You're going to have to find a way to use the rule here. But here's the problem. They did not label the lines. You all seen how we did integration as to the top? Yeah. Victoria, take ahead. Yes, you sure? Right, so what's the first thing you have to do after you find the which equation is which? What you have to do?
Yeah, it's. Right.
So right, so no, but the first thing I have to do is find A, B, and C. The first thing you have to do is to find A, B, and C. But in order to get A, B, and C, we don't know which equation is which. You all realize that? Right? Keisha will help us figure out which one is which, but watch this here. After you figure out B, and you figure out A, and you figure out C. You'll see how we can integrate now? So you can integrate A and B, B and C, minus them. You can integrate A and C, B and C, minus them. Okay, and then find total. So you can find A1 and A2. Yeah? Okay, say enough? Right, but here's the problem. Before we do all that, how are we going to find A, B, B, C, A, C? Look at the equations they gave you, Keisha. Right? Look at the equations they gave you. Which one will correspond to the particular line? They did not label it. That's not okay, Keisha. Now we can figure it out. How are we going to figure out which line is which? Keisha, how we can do? No guess. They must. There, all the lines are not the same, obviously, right? What they have different ones. What's the lines? They have different gradients. They all slope differently, right? You're seeing that?
Yeah.
Which ones have a positive gradient? Excuse me, sir. Say it again. A, B, and B, C. And which one are negative gradients? Which has a larger gradient? A, B, or B, C? A, B has a greater gradient. That's so look at the line here. Look at all the lines. The first thing we should do is put them in the form. Y is put them in the form. Y is equal to mx plus c. Here, put them all in that form, right? Okay, shall we see that now? So the first one is y is equal to 3x minus 7. The second is y is minus x plus 9. And the last one is y is equal to 1/3 x plus 1. Right. So help me leave it. Which one do you think is let's start with negative gradient first. Which one is AC? First, second, the third line. AC is negative gradient. Which one? Sure. Negative gradient. Second one, right? You're seeing that? This second equation is negative a negative gradient. So the second equation is AC. Wait, between the first equation and the third equation, which is AB. Why? Yeah, AB. Why? Because the gradient is larger. The gradient of the first one is 3, and the gradient of the third one is a 2. That's okay? Is that okay with that? Right, now find the area of these, find the one and A2. Find A1 and A2. Find A1 and A2, please. Right, put the right line on top, right? Sorry.
Checking if the answer wrong.
Right, right. You can use excellent. Okay, find A1 and A2. Pay attention to which line on top, right? Which function on top. AB on top, right? A1, AB on top, BC underneath.
Oh, that's why, look. No. Right, let's find it, let's find A1 and A2. No, yeah, that was it. No,
What I did there was when after we get stupid already. So some of you are not simplifying, you are not simplifying A, B, and B, C, you are simplifying and then integrated. I think put what's up user needs that. Going to be easier at one time. We also look at it. Yes, sir.
Oh, you know why? Because equals 3x minus 7 is equal is 80.
Because AB, the gradient is 3. And B, because I equated y times x plus c.
Yeah.
Well, when in front of x,
Well, sure, because the next one will be next ingredient.
like next one is a smaller
And
gradient.
next one is smaller ingredient. Yeah, that makes sense.
Right, so of course, you have to solve simultaneously. I'm not doing that part, right? I just doing the area part.
So fine, with
So A1 is the integral, you have to find A, B, and C. E1 is the integral between oh, I didn't write the values. B would have been 3. A would have been 4. And C would have been 6. Right? So therefore, between 4 and 3, you're minusing A. AB, which is 3x minus 7 minus BC. BC is 1/3 x plus 1. Right? So we're going to integrate between 4 and 3. 3x minus 1/3. That's 9 minus 1 is 8 and 3x. That's minus 7 minus 1 is minus 8. Right? Then you integrate it. You integrate between 4 and 3. The integral of 8 to x will be 4x squared on 3 minus 8x. Right? And then plug in 4 and 3. Yeah. Change color. From the red. Alright. Well, I guess for the first part there, when you plug in 4 and 3. What shall I get for A1? What is that? 8 on 3x minus 8. Because a minus AB and BC. Am I right in blue to play sharper? Here is AB minus BC.
Ready?
yeah, right.
Yeah, right in blue.
Alright, and then blue now.
We just don't have it.
What is A1? Look up. Anybody can just plug in 4 and 4. What? 4 and 3. Anybody else get that? 4 and 3.
Yes, I do.
Remember, you can put this whole thing in the calculator and check the answer. Yeah. No, check the answer. You'll best you can write it down. Four and 3.
That's
That's the part I get 4, but
still, that might not be that.
Huh?
That might not be.
yeah, minus 8 times 0. Anybody else get 4 over 3? Right, find A2 please. How much again? After you plug in, it's the same thing. Plug, find A2 one time. Because look at it one, look at it value, 400 EMP. One, EMP. Very personal is. Oh, yeah, we got A too fast there. Like one of Oh, yeah, we got A too fast. At the top, right?
So again, I get and when you country.
I still have. Integrate between 6 and 4. AC minus BC. AC is where AC going? AC is minus X plus 9 and BC is 1/3 X plus. Right, so then it integrate between 6 and 4. What will that be? Minus 4 and 3. Minus 9 minus 1 is minus 10. Anybody got that? Anybody got that? To integrate. Minus 4x on 3 minus 10.
Yeah.
That's where you have to integrate, huh? And then you plug in 6 and 4.
Minus
Oh, shucks, no, sorry.
and minus 8.
Plus 8,
Plus 8.
plus 8. Plus 8.
So the minus 4x on 3 plus 8.
Yeah, plus 8. Integrate between 6 and 4 and tell me what you get for A2.
Okay.
Integrate between 6 and 4. Oh my god. That's a
Yeah, yeah, done 3 too.
And then add it and you get 4 at the answer. What's the next method that we could use earlier? To find the area, the shaded region. Not integration, but the next one we could use. Huh? 4 units squared. What's the next technique that we could use here? What shape it is? To find the length of the line, then find the area, right? All right, next one. So that was how you handle something like this, right? Or again, a people one.
Yes, sir. Again, after.
Okay, all right.
No basket. Yeah, no.
Okay, but two questions.
Like, no,
Get it.
Yes. Hit the cup. Nah, it's not far, or it's not all.
Ah, 8 and 3, so these two others 4. What's this one here? Oh, shit.
Yeah, but yeah, number.
All right, let's take a look. Oh, wait, I just go to this one here.
Okay.
Right, what you say now? Marquis. Calculate the volume of the solid generated by revolving the region bounded by the line and the parabola about the x-axis. Right? Same formula. All you have to do is figure out which produces the larger volume and then minus. Okay, so same thing as that volume formula, that the first one. But you have to figure out which will produce the larger. Which will produce the larger volume between 0 and 1. Can you all think the curve or the line? The line. Okay, not the line will produce the larger volume. Kind of shaped like a what? Kind of cone? Part of a cone. Right? But when you rotate a straight line, well, sorry, a line slants like that. across the x-axis, what shape will it form?
Wait, what? Oh, you trying to find that and that?
We're trying to find the volume in between. You're trying to find the volume in here. Watch. Yes. Watch this fast. Right, the volume of solid generated by revolving these two. You want the volume in between. Okay. So question number 1. What are the limits? 0 and 1, right? Question number 2. Well, which one to minus it? Right? Which one on top? The line bigger, right? So it will be 3x minus 6 all squared minus the cube all squared. Right, try that please.
So, if I on the positive side, right?
You find on the x between 0 and 1. So yeah. So watch. So the volume is watch fast now. The volume is where? The volume is between 1 and 0 pi y squared, right? So the one that in front is what? The one that in front will be the 3x minus 6 squared. And then you have x squared plus 3x minus 2 squared. All right. So those are the functions that you're squaring and then working it out. But please work out this first, right? Work out inside the brackets first and then work it out.
Oh, yes, it's
75. 2023, I think. After this one. I don't think. Oh yeah.
what?
3. Yeah. You will put the calculator. Huh? Oh yeah, square it out and minus and simplify, right? Right, down a little bit here, right? How much again? So when you square this, when you, I take your time when you expand this, right? It'll be x squared plus 3x cubed minus 2x squared.
So Darius, I'll get one from the yeah. Yes.
Huh? Yeah. Yeah, so yeah, this by the two terms, this by the two terms. Yeah, because remember it will be what? This by this is this. This by this is this. This by this is this. Correct? Well, yeah. By the next two terms, that's what I'm, yeah. So it's three terms in order.
X squared. Minus 12x. Plus 4.
Right, that's already. Slow down. Right, so you all follow how I expand this? See that? Follow how I expand this? How did again, Killer? How I expand this again? How I expand this? By doing this, right? Right? So I multiply x squared by all three terms. 3x by all three terms. And I get this long thing here. Right? So therefore, what did we end up with? 9x squared minus here, right?
Stop with the negative corner. I mean, negative x power 4.
No.
But in order, no.
Yeah, do you know that? Sorry for me.
But in negative,
I don't want
have
that.
a higher.
I don't want. Alright, minus x to the fourth. You happy now?
Yeah.
Minus 6x cubed. Minus 5 plus 9 is plus 4. Minus is 12. 12 plus 36 is
24.
minus 24. 36 minus 4 is 30. Nice. And then yeah, you have to integrate it.
Integrated on.
What?
It's easy.
Right, and just plug in the answer.
515. But
And then-
no, I want to see where I went wrong.
How you know you went wrong?
I get a different answer to Yash.
Yeah, I get it.
So how you know you went wrong?
Because Yash put the entire thing, he got
So how you know you went wrong?
he can't get that, but he high smart, he can't get that.
Oh, you actually the wrong thing?
Right, and he'll get 12.
And you will get 0 here, right?
Yeah.
When you plug in 1 and 0, right? You'll get 0, so that's plugging in the 1, right? So minus 1/5 minus 6/4 plus 4 and 3 minus 12 plus 32.
Right. When I get that, I
And
get
work it out and multiply by pi, right?
679 over 35.
When you work out this whole thing?
Yeah.
Check it back and make sure now. Let's work out this. Bam 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 bam.
Down there we go. 6.
How much we end up with here?
580.
How much?
580.
589 over 30.
Yeah.
5.
Yeah.
Okay? So the only thing that's difficult is you have to remember how to square this, right?
Five eight nine. Yeah, I put some. So I put now, I will be going next year.
Otherwise, break, all right, 5 minutes and then we go again, right? Find out. It's not minus, it's not one. What it meant, like what those represent, people doing and all those. And where the diagram might come from. Alright. Okay, so there is one, two questions that I want to take a look at again in integration. And then we will Anybody's not possible book that? Okay, that's possible. Alright, so let's just talk about this one here, right? Before I put it back on the board, it was something that we did last week, but I didn't do an example that had limits. Alright, suppose we had to integrate something like this, right? But they told us to make a substitution. Right? How you would integrate it? What the first thing is do again? Yeah, you have to find what? You have to find du dx. And then after you find du dx, you make a substitution. Right? Right. But we have a slight problem that will happen. Right? We have two problems. Problem number one is that this x will still be there. How you get rid of that? Make a subject from here. Yeah. You know, you could have, but they said to use this. Right? But here's the problem. What is happening, Keshav, when you have limits in terms of x and you want to write an integral in terms of u? These limits are the limits of x, right? So you can't have, let's just pretend you had u by 1 minus u. You can't have 1 and 0 here because those limits belong to the limits for x. So what we need to do is find the limits for u. So when x is 1, 1 minus 1 is 0. And when x is 0, u is 1. So these are our new limits. Yeah. That's okay? So these limits are the limits for x. You okay with that? So I can't use the limits when I have an equation in terms of u. All right? So what I have to do is find the limits in terms of u. So when x is 1, 1 minus 1 is 0. So I'll put the limit as 0. When x is 0, u is 1. Right? And then you integrate. But we have one side problem here, limits upside down, right? So you just find negative sign when that happens. Okay? So I want you to try that coming up, please. Try this one. Right, so I just want to point out something. These are the limits for x. Right, so to get the new limits for u, we substitute x is 1 and you'll get u as 0. Substitute x is 0 and you'll get u as 1. Then set up your integral between 0 and 1 and work it out. Why are putting the minus sign here? Putting the minus sign because the limit's upside down, right? Supposed to be high then low. Oh yeah. Try that, please. Right? Yes, that's like what now we were doing, right? Right. You're done? You're done? Oh yeah, so du dx is minus 1, x is equal to 1 minus u, right? Right, so again, for those who now come into the class, right? Right? The problem here is that the limits of x was 1 and 0. I can't write 1 and 0 here. So I converted the limits of x to the limits of u. When x is 1, I got u to be 0. Plug it in here. When x is 0, plug it in here. I solve u is 1. So the new limits are 0 and 1. I put the minus sign because the limit's upside down. It should be high and then low. Okay? Now I'm gonna make a substitution x by u squared dot du on minus 1. Okay? Remember, x is 1 minus u, so I can't leave this here. So I put in 1 minus u. And then you multiply it out.
Yeah, but you can bring up a negative one and get positive.
Huh? Yeah, you can do that. Right? So you'll end up with what? U squared by 1, which is u squared minus u cubed. And then you work it out. You'll get u cube on 3 minus u to the 4th on 4. Plug in your 0. You will get 0. Plug in your 1. You will get 1/3 minus a quarter. And when you work it out, you'll get 2. I got 1/12. Anybody else get up? Can I go again? Yeah, 1/12. What do you get? Pardon me? Yeah. Yeah. Where you come from? Yeah. Yeah, mom. I differentiate this, ma'am. Because you have to make DX the subject, ma'am. Yes. Talk now.
Darian.
All right, so last one, I'm done. All right, you can start taking that picture, right? Vinesh, how are you doing this?
Yeah, question, I listen.
Nobody asked you that, Darian. Darian, who asked you that? Who asked you that? Right, how are we doing that, well, yeah? Anybody else? Jacob. Jacob, how we showing this and this same thing?
So you'll just put it in and then again.
Or what if you factor out the integration sign and DT, you end up with that, but they wanted to use this to show the same thing. So you're substituting one here, integrating, and then doing it separately and showing you get the same thing.
Yeah. You want to do it?
Yeah, 5 marks. How many done? That's plenty, 5 marks for that.
8 marks.
We'll figure it out. Oh yeah, please, excuse, sorry, I'm there, please. Last question, try that.
Money to see.
Right, so you get over the left hand side first and then you get right. Okay. Right,
No, you want to see the back side.
I just do like
So when you integrate it, right, is 1 over E, right? And here.
right, do the left hand and the right hand, you done, right? Huh? Fine, the Philippine. I'll use that later. Right, so do it quick. Right, add them up, you'll get 2 cos t plus 4 sin 5t plus 3 cos t dot dt. When you add it up, you'll get 5 cos t plus 4 sine 5t. Anything else we could do there to bring them together? Nope. So let's integrate. So you'll get 5 sine t minus 4 over 5 cos 5t. That's all we can do, right? Plus c. Do the right hand side separately now. Integral of 2 cos t dot dt plus the integral of 4 sine 5t plus 3 cos t dot dt. This will be 2 sine t plus this will give you 4/5. I'm doing them separately, right? 4/5. Sorry. Minus 4/5 cos 5t plus 3 sine t plus c. 3 plus 2 is 5 sine t minus 4/5 cos 5t plus c. That's it, the identical. That's it, QED. Alright, so technically we just do it on both sides and working it out, right? Right, so that's it to the end of module 3. Right? We'll be doing 10 different, we'll be doing more questions in fact course, right? I'll give you questions that we didn't do in class as well, plus past papers. Hopefully at the end of crash course, they have solutions like 5 or 6 years plus some more. Right? And during this period here, try to identify where you're still having no problems. I think if we do like TMI, you're struggling with trades. All right. All right.
So,